It is expected that in the next decades we will see a shift from the so-called passive distribution network to the smarter or more controllable active distribution network. In this video, we will address this topic. You will learn the main differences between the current passive distribution network and the future active distribution network. We will focus on aspects related to the integration of distributed generators, control, and information exchange between the different actors involved. In the near future, distribution networks are expected to take a more active role in the operation, control, and monitoring of electrical networks. In this way, they will become the so-called active distribution networks. According to the definition given by Sigre, an active distribution network is an efficient platform to control a combination of distributed energy resources, including distributed generators, loads, and storage. Under this scheme, distribution system operators have the possibility to manage the electricity flows using a flexible network topology. A very important characteristic of such networks is that the flow of power becomes bidirectional. Also, decision-making and control become decentralized, instead of being performed at a centralized authority. Nowadays, most of the existing distribution networks are passive. In this case, the power flows unidirectionally from the upstream to the downstream network. Both voltage and frequency control are performed exclusively at the generation and transmission sides. The traditional distribution network needs to evolve in order to facilitate the access to distributed generation in high shares and to enable local energy demand management. When the distribution network is transformed from passive to active, the power will flow bidirectionally, either from the upstream to the downstream network or from the downstream to the upstream network. Voltage and frequency will be monitored not only at the generation or transmission sites, but also partly by the distribution network operators, where the respective remedial actions will be taken. And finally, thanks to the active management, there will be an increased capability to integrate renewable energy sources and storage units, and the possibility to apply demand-side management strategies. Another major difference between passive and active networks is the way to manage network operation and information exchange. In passive networks, there is a low control and monitoring of distributed generation renewable sources, often performed by the transmission system operator. Also, there is a lack of regulations when it comes to distributed generators' contribution. As mentioned before, active networks have the potential to feature tools to manage distributed energy sources. To allow this, flexibility support will be required between the distribution system operators and transmission system operators. Additionally, new system services for distribution system operators will have to be arranged via commercial ancillary services and grid codes. Information exchange is currently a topic of attention because in passive networks there is little or no communication between transmission system operators and distribution generator owners or distribution system operators. Active networks require structured and organized offline and real-time information exchange for their effective deployment. When information exchange is enabled, there are some important potential benefits that come with the implementation of active distribution networks. First of all, they may allow the integration of distributed generation, demand-side management, and energy storage, thanks to the higher flexibility. Second, opportunities for novel services may be created when a change in distribution network structure and control is carried out. Another potential benefit is that power generation and consumer demand can be efficiently matched through the implementation of information and communication technologies, or ICT. This can be achieved, for example, by the use of forecasting methods and demand-side management algorithms. Moreover, unlike passive ones, active networks have the potential to support standalone operations since generation is decentralized and it is often coupled with storage units. Additionally, the proximity of distributed generators to the demand sides makes it possible to obtain a reduction in transport-related losses. Finally, active networks have the potential to provide the network with support by relieving congestion and offering restoration after faults, among other ancillary services. The proper operation and control of active distribution networks is a big challenge. Many technical aspects still need to be studied and implemented. We can mention here a few of them. First, the main technical challenge is related to the control of large number of distributed energy resources, such as photovoltaics, but also, for example, wind and traditional diesel generators. Second, substantial investments will be required in order to make the current distribution networks smarter and to offer both offline and real-time information exchange. This means that the introduction of distribution system automation will be gradual. Another challenge in active networks is the implementation of voltage and frequency control through the larger use of power electronics and communication technologies. To sum up, in this video we have seen what are the main differences between traditional passive distribution networks and active distribution networks. You learned that active networks are designed to allow bidirectional power flow and local control. Also, active networks feature distributed generation, which may allow transmission power losses reduction and standalone operation. Finally, we discussed some aspects that need to be further investigated in order to ensure a correct operation of the active networks, namely, high integration of distributed generators, investments on the distribution network, automation, implementation, and power electronics-based frequency and voltage control.